New derivatives from old. When new functions are formed from old functions by addition, subtraction, or multiplication by a constant, their derivatives can be calculated in terms of the derivatives of the old functions. In particular, the following formula says that the derivative of a constant times a function is the constant times the derivative of the function. So here's the definition: the constant multiple rule. If c is a constant and f is a differentiable function, then the derivative with respect to x of the constant times f of x, you can factor out the value of c and then take the derivative of that function. Okay, so let's take a look at the proof here. If we let g of x equal the constant times f of x, then g prime of x is going to equal the limit as h approaches 0 of g of x plus h minus g of x over h. Now, if we take that constant and then multiply it by those functions, that means it's going to equal the limit as h approaches 0 of c times f of x plus h minus c times f of x divided by h. And so the value of c we can factor out. So therefore we have the limit as h approaches 0 of c times f of x plus h minus f of x divided by h. And then by the law 3 of limits, we can then factor out the c outside the limit. So it's going to be c times the limit as h approaches 0 of f times x plus h minus f of x divided by h. And therefore, that's going to equal c, the constant, times f prime of x. Now, we also can take a look at the geometric interpretation of the constant multiple rule. So here we can see that here's a curve, y is equal to 2 times f of x. Here is a curve where y is equal to f of x. So multiplying by c equals 2, what it does from this curve to this curve is that it stretches the graph vertically by a factor of 2. So all the rises have been doubled, but the runs stay the same. So the slopes are doubled too.